Hello and welcome to another edition of Antisyphon's address-based layout randomization. My name is John Strand. It's kind of a little bit of it's kind of quiet, Ryan.
It's
It's just
nappy
you and
time.
me. Yeah, well, we were just discussing the importance of taking a nap periodically. We think it's absolutely, like
so
critical.
so
So
this is the ASMR edition. No, it's
yeah,
not.
this is the closest one. Ryan could probably sleep to me talking now. He's like, it's okay, it's okay. He's making noise.
Oh, and then
Um,
of course, Brian here. Good morning.
Show off. Show off. Shouldn't you be doing some work, Brian? But no, this particular episode, we're going to do something technical. Yesterday, we were doing something non-technical with Kevin. And today, we're going to be going through something technical. I think I may have done this topic, Ryan, but I think I did it like way fast. That's whenever I was trying to do everything like in 15 minutes. I'm sure that there's a joke in there somewhere. You can keep digging for it. But today I wanted to go through, some Windows Live forensics. Like if you get a hold of some malware, how can you actually do some analysis on that malware? So
All
with
right.
that, if you have any questions, folks, just type them in and be sure to tell me to Zoom periodically just to make sure that Zoom works. As always, I'll be doing this out of the labs that exist inside of the Intro to Security, Intro to SOC core skills, and the Cyber Deception courses. Just showing that off so you all can kind of jump in if you want. You can actually download the VM. I can share that link or somebody will grab it here in a little bit. Actually, let me get it to Ryan and then Ryan can get it to you all. I mean, you're not going to be able to do this. You're not going to be able to do this like in 30 minutes that we're going to be doing this right now. But if you want to come back and go through it, you totally can. We make this VM available. Ryan will get that out to all of the
Got it.
distributions. There we go. We'll get that out to everybody. So this is the VM that we use for the class. And like I said, I think I did this, but I went like way fast when I went through it. So I wanted to go through it a little bit slower. And I wanted to answer any questions that people may have about doing live forensics. There's a bunch of really cool like videos out there where people are talking about how to do analysis of like dead malware using IDA Pro or Ghidra or things of that nature. But if you're sitting and you're looking at a computer and you want to find out if there's malware on that computer, what exactly would be the commands that you could do to kind of do that, stepping through it? All of a sudden, all of my stuff just completely changed on me, but that's okay. It looks like the stream is still working okay. Ryan, you okay there?
Yeah, we're still here. We're good.
All
So
right.
far,
Just
so
want to make
good.
sure we can see things. All right. All right. So what we're going to do is we're going to go through this lab and I'm going to explain what's going on in a little bit more detail. Now, of this particular lab for this course, moving things back to where they belong, for this particular course, what we do is we start by creating malware. And for our malware, we're going to be using like Metasploit. And the reason why I like to use Metasploit is it's freely available. Anyone can use it. It's an incredibly handy tool. Even though if you look at a lot of attackers that are out there today, they're using tools like Cobalt Strike or Brute Ratel, or they're writing their own malware. And you shouldn't get too wrapped around the axle about what the malware is per se, but you really should be looking at the process as a whole. I've got a question right now from Justin. He said, maybe a dumb question. We'll see, Justin. We'll see. If you're doing these investigations on a user workstation as part of threat hunting, can you remote and investigate without interrupting the user's work? Yes and no. So there's a bunch of different tools that exist out there, like F-Response and F-Secure, where you can actually do remote capture of computer systems. And you can pull down like the memory from that computer system. You can pull down something called CAPE. I know the K stands for crawl. But what CAPE actually does, and somebody will find it and type it in, I'm sure. But what CAPE is a lot of incident handlers and a lot of forensicators, they actually call themselves that. They actually do call themselves forensicators. They identified that there's like, let's say 25 things that they always look at when they're doing incident response. And CAPE is a subset of the entire system. So it allows you to pull down a smaller subset of those artifacts so you can start doing analysis on those artifacts while you're pulling down the entire memory and while you're pulling down the entire hard drive. So it's called CAPE, K-A-P-E. Juan Sebastian Lopez Villa says, in terms of chain of custody, which precautions should we take? All right. So as far as chain of custody, one of the things that's important is actually establishing procedures. And I recommend going out and finding cheat sheets, live forensics cheat sheets, or even referencing this, what we're going to do. It's on the wiki. On GitHub. You can pull down the wiki from GitHub, and you can reference that, and you can go through these steps. Now, whenever you're going through these steps, it's fine if you deviate. You just have to annotate as part of your incident response that you followed these procedures, you deviated for these following reasons, and screenshot like crazy, right? And document as much as you possibly can. As far as that chain of custody, whenever you're taking evidence, let's say I'm taking everything that we're about to do in this lab, and I shunt it to files, I would go through and do a SHA-1 hash or SHA-256 hash of those files to make sure that they have not been modified. And then I would keep it on my system, and I would note where it is, or I'd copy it to a USB drive, put it in a save. Now, those hashes are really important, one, and this is going to have a point to it. In the Daubert Rules of Evidence in the United States, evidence is admissible in a court of law as long as there is no evidence of quote unquote tampering. That means that there's no evidence that somebody changed it or modified it in any way. So if you have hashes, and let's say that you accidentally left a USB stick, like you left a USB stick in your car, that's still admissible in court, according to the Daubert Rules of Evidence, because you hashed all of the data on the USB stick and hopefully the entire USB stick. So don't throw it away because it was maybe left unattended for a period of time. So always do your best to document, but creating those hashes and tracking those hashes is absolutely essential. So hopefully that answered your question. All right. So as I said, for this particular lab, the goal of this lab is not to create malware that bypasses antivirus engines. So what I'm going to do is I'm going to run this command that actually disables Windows Defender on my system. And I know that this is lame. Okay. Like I totally get that there's people like, well, it's really cool. You bypass AV. When you're looking at bypassing AV, it's an art much more than it is an actual science. It's not like do the secret handshake and you've bypassed antivirus. And honestly, if we went through and bypassed AV today, then by tomorrow, people that would follow through with this lab would be detecting it all over the place. So really, we just sidestep that because that's not the goal of what we're doing here. And if you get this red error message on my VM, that's good. It means AV is not running on the computer system. The next thing we're going to do on the Linux system is I'm going to run ifconfig. All right, I'm just going to start up an Ubuntu command prompt. I'm going to run ifconfig, and I'm just going to get my Linux IP address. We need this because we're going to create the malware. In the malware, we're going to create a type of malware that does reverse connection. So it's a reverse interpreter session is basically what we're going to be creating here. And as an option in our malware, we're going to be putting in the IP address for the reverse connection coming back to my system. And this is all running locally on the exact same VM. So it's really slick. We're using Windows subsystem for Linux for running the Linux stuff. And then we have the Windows system. So we actually have a completely separate adapter for a Linux kind of, I don't want to say VM. You could say it's a virtual machine that's running, but then you would think it's VMware, and it's really not actually VMware. So I've got that IP address there. So that's exciting. Now what I'm going to do is I'm going to become root. All right. On my ADHD system right here. Become root on my ADHD system. Password is ADHD. I just gave you all my password. Oh no. And I think I mistyped it. How ADHD is it to mistype the password of ADHD? And then I'm going to run this command that's going to create the malware here. Okay. So there we go. And I've got to change one of the parameters to my Linux IP address. So I'm going to copy that. And I'm going to put it where it says your Linux IP address. I'm going to put in my Linux IP address. Okay. So what we're doing is we're running MSF Venom. I just got something is wrong. Ryan, can you hear me okay?
I hear you just fine.
All right. It looks like we're back. All right. So I got something is wrong, trying to reconnect, which is crazy. All right. But as long as you can see me and hear me, we're good.
So far, so good.
Thanks, man. I'm going to be running MSF Venom, and MSF Venom is part of the Metasploit framework. And specifically, what it does is it actually wraps two different tools: MSF Encode and MSF Payload. Used to be you would run these two separate. Like you would go through and run MSF Payload to create your payload, then you would run MSF Encode. And really, MSF Payload is basically a utility that allowed you to modify, or excuse me, allowed you to export Metasploit payloads in a variety of different formats, right? And then you could use MSF Encode to avoid bad characters. Initially, that's why it was created, was to avoid bad characters. And the reason why is if you have like 00 and a string copy function, everything after that dies. So you want to strip that, or AF or FF, or a number of different opcodes that can create issues. And what they did is they rolled MSF Venom in. Basically, it has both of those tools. So we're just going to create a simple, 32-bit architecture. Platform is going to be Windows, and the payload is going to be Windows Meterpreter Reverse TCP. Okay. I'm not getting fancy with this at all. The goal of this is not to get super crazy. It's just trying to create a little piece of malware. That's all we're trying to do. And then we can look at it as well. I see Rook is on, which makes me nervous because Derek Rook is awesome. I think he was on last week, wasn't he, Ryan? A couple weeks ago, we had Derek
A couple
Rook on.
weeks ago.
Yeah, and he was talking about Linux file permissions, which was awesome. So go check that.
Yeah,
Ryan.
a lot of people like that one.
That was really cool. But no, he's smart. He's really smart. So we've got Windows Meterpreter. We're going to be doing a reverse TCP. Okay. And then I'm going to set the L host to be my Linux IP address. The L port is just 4444, which is the default, right? Just simple. And we're going to output it executable. And then we're going to give it a file, trustme.exe. We're going to kick this out. Takes a little while for it run, just to kick out. Just a little bit of happy malware. Just it's all we're creating here. It's my goal to be the Bob Ross of security videos. There we go. So there we've got the payload size is 341 bytes, and the final size is 73,000. All right. Now, what's going on is the actual malware is really, really small because we actually don't have the malware in here. What we're putting in is a stager. It's just a little piece of malware that reaches back and it grabs the rest of the meterpreter and then loads it up into the victim computer system. So that's why trying to do analysis of executables can be somewhat problematic. I mean, it's a good skill to have without question, but if you're looking at just the initialization executable, a lot of times it's super, super, super small and it's just a stager. And then all it does is reach back and then grab the rest of the malware and it slaps it right up into memory and it allows it to execute. So there we have trustme.exe is saved into temp trustme.exe. So if I cd into the temp directory, type ls, you can see we've got trustme like that. And we can see it has actual file size on it, which is pretty cool. I'm going to try something different. We're going to go ahead and we're going to copy trustme. And I'm just going to copy it to mount C, and let's just put it right into tools. We're just going to move it right into there. So what's SU? So what that is that's switching a user, right? And there's more to it than that, hoax Paragon. Whenever we put the little minus after it, we're bringing the environmental variables as well whenever we switch the user, which is really cool. Because if you don't bring that minus as part of the command, a lot of times whenever you just SU, it basically brings nothing for environmental variables. And you got to give the full explicit path to everything. And the minus doesn't mean root. Because we didn't specify a user, it automatically is implied that we wish to become root as well. So by default, it's just going to take you into root. So hopefully that answers your question on that. So, and just type in questions anytime. That's what we're here for, right? This is more interactive than anything else. So I'm going to copy trustme over to mount C tools because we're using Windows subsystem for Linux. It makes it really easy for me to transfer the malware over to my Windows computer system. So now we have trustme.exe over in that directory. Now, we're not done yet here. We're not, because what we need to do is we need to set up kind of the command and control server. So we need to set up a server that receives this reverse connection coming off of this computer system. So let's go ahead and let's set that up. I'm already root. I'm going to do MSF console like that. It's going to take a few seconds, and I'm going to get an error. It's going to say the copy of this version of Metasploit is more than 2 weeks old, because it is. It's actually, I think it's coming up on a year old. Doesn't really matter. All the commands that we're doing here are just absolutely, super basic Metasploit commands. No black magic with this whatsoever. I'm not going to use netcat. I'm trying something new here as well. I'm starting something new here. We're going to use exploit multi-handler. Copy that. Put that in there. It's neat. I'm going to go ahead and Control L to clear off my screen because it's getting a little cluttered. We're going to set the payload to be Windows Meterpreter Reverse TCP, like so. Now we have two things that we set up. We set up the actual exploit isn't an exploit at all. It's just multi means operating system. So anytime you set up exploits, they're broken up in operating system. So you'll have the exploit would be use exploit Linux, use exploit Windows, use exploit OS X, and then the actual service that you're trying to exploit. But in this situation, we're just setting up the multi-handler. Works for multiple different operating systems, and it's a handler to receive those reverse connections coming back in. We're going to set the L host to be the Linux IP address of our system, which we have conveniently enough up here. So I'm just going to take that. I'm going to copy that down here. Then we're just going to do exploit. Now, when we run exploit, we aren't exploiting anything really. It's just setting up the multi-handler and waiting for those reverse connections. So it's like a catcher. It's waiting for the ball to come back. So what we have to do is trigger the malware and then get it to throw a connection back to our Linux system. So to do that, we go back and we create a new prompt on our Windows system. And then I'm going to run trustme.exe, which we moved over. Thank you very much, Juan. Crawls, artifacts, parser, and extractor, CAPE. So we might need to do a whole session. We just bought our CAPE license, just re-upped them this year. So we might actually do a video on CAPE, which I think is pretty cool. So I'm going to run the malware. If I go back to my Linux computer system, you can see that I have a Meterpreter session, and I can see the files of my Linux computer, my Windows computer here. So I have all kinds of cool stuff set up. I'm going to get a shell on my Windows computer system just because you don't feel complete in life until you get a shell. So there we go. We got a shell. So we went from a Meterpreter session to a shell. This is running on my my Windows computer. So if I do ipconfig like so, you can see this is my Windows computer system. So we've got access. So now the malware is running. All right. So we've got malware running on our Windows computer. So now let's actually run some commands that we can look at as far as detection, right? And these are all the instructions that exist. So the first thing I'm going to do is I'm going to create a share over here. Now, the reason why we see attackers that create shares, which is just like a stupid, simple command. But a lot of attackers, once they get access to a computer, they'll set up a share and then they'll pivot to other computer systems. And then what they'll do is they'll grab files and then they'll move it over to one of the systems that they've compromised. And then they'll basically roar up the malware, not the malware, the data that they want to exfiltrate, and then they'll exfiltrate it off of the environment. So we just created a share on the system. So really, really, really basic. And then on our Windows computer system, if I go back to my command prompt as administrator, which is key, I'm running as administrator. If I run netview and I put in 127.0.0.1, you're actually able to see that there is in fact a share that I created called class. So we're looking at, if we think that the system is compromised, what are some initial commands that literally anybody can run? Like this could be like if you're sitting at home, you're like, oh, I think my system might be compromised. And by the way, if you think it's compromised, it more than likely is. I'm just going to say that. If you're like, something doesn't feel right, and there's a glitch in the matrix, and porn isn't loading as fast as it used to, you're probably going to be compromised at that point. So with this, we're starting with looking at share. Now that's more of a corporate level one that you'll be seeing the shares. If you're looking at this in your home network, not so much. Oh my God. Static tear. But you can't compromise my system on a Mac. Yeah, that's right. Because Macs don't get viruses. I know this because Steve Jobs and what was that guy? Justin Long? Was that his name? Those I'm a Mac videos that were just lies constantly. Yeah, that's who was actually creating those. Now, the other thing that we can do is we can create a session, and I'm not really like, once again, this is all local. I just created a session on created a Z drive session on my own system. But once again, an attacker post exploitation, they like to mount shares on remote computer systems. So here you've got a share, and we can see the share with the command. We can run net view to see the shares on the computer system. But let's say that they mount a share. How can we actually see that they've mounted a share? So here you can see we've got net use star. That means it's going to start with the next available drive letter, starting with Z. And we're just mounting a share to ourselves on the C drive, which is your hard drive of your computer. Now, an attacker, if this was a real environment, they would put a remote IP address, like in a domain environment. They'd put in a remote IP address and mount a share on somebody else's computer, which is interesting because in Active Directory environments, if they were to run this, it would pass their credentials to that system, and then it would allow them to log in. So it's really wild. Like once you're in, you're a G in Active Directory. Once you've got a valid Active Directory credential, you can use it. There may be some limitations on what you can do with it, but you absolutely can still use those creds. So from our hacker computer, we're mounting a share, and it turns out we can actually look at the system that's compromised, and we can identify whether or not we've got a share like that. And here you can see, yep, sure enough, there's a share, a Z share. Now, one of the things you absolutely have to do if you want to be good at any type of incident response is know what's normal in your environment. Is it normal for there to be a class like share? Is it normal for there to be a mounted like Z drive for files and things of that nature? Get to know what's normal. Run these commands before you get into an incident, and you'll do much better in the incident. Got a couple of things. Brandon Johnson said, pass the password. Actually, it is different. You're not actually passing, you're actually passing a domain token whenever you actually do that. So it's not even past the hash, really. It's just an active Kerberos token. Is what you're doing. So there's no magic there. Hoax Paragon, or no, wait, Bonzi56 said, get the hash, crack the hash, use the hash, words to live by. I used to tell my students to tattoo that on their arms, right? Now it's, report as you go, which is less sexy, right? If you like, hack systems, get password hashes, crack the hashes, use the password hashes. That sounds like self-help, right? But if you're like report as you go, it's like, you might as well be tattooing brush your teeth. It's important, but you need to be doing them. So that's what you're doing that. It's not the first time I've sold a password for a Snickers, right? And Sheena Peacock, baselines for the win. Absolutely. All right. So now let's kind of move out of this and let's actually get into the Netstat command. So we know that we have a connection on our Windows computer system, and I'm just going to run Netstat by itself. Rook said Netstat, and he's absolutely right. But if I just run Netstat by itself, it just gives me some very, very basic, connections, right? And it's not really giving me a lot of information, right? It's not giving me a tremendous amount of information, but sometimes less is better. Sometimes less is more, especially on a Linux command line. So with this, we can see that we've got Kubernetes connections that are made. Those are normal for the system. But then we have this weird connection right here, right? So we have this connection to our Linux IP address on port 4444, and that is our malware. Juan brought up a question. Do you recommend using Google's GRR tool to doing hunting remotely? To be honest, at this particular point, instead of using GRR, I'd recommend using Velociraptor. One of the main developers at Google left, and he was behind the Project Recall. He was behind GRR. And he started up his own project called Velociraptor. Someone will grab a link and throw it in here in just a couple of seconds. But look at Velociraptor instead. It's kind of like the next iteration of GRR. And currently it's maintained, and Rapid7 actually helps maintain that project, which I think is really cool. So hat tip to Rapid7 for all the open source projects that they contribute to the community, which I think is awesome. Now, as I said, the Netstat command by itself is kind of poopy. So what we want to do is make it a little bit spicy. So I'm going to run netstat minus naob. And that's going to show all the connections. The O will actually just build it out. So if I do na, China. Oh my gosh. I'm sorry. Sorry, China Peacock. My bad. Apologies. All right. So now if I do this, if I do NA, it's now going to show all of the connections. And I'm not going to resolve anything on that. So what we're going to do is get some value out of this, because once again, we're just getting ports and foreign addresses, which is just numbers and stuff. And I don't know. A lot of people hate math. So we're going to do NAO. And if I add the O, it's going to add the process ID, which is super cool over here on the right-hand side. So now I'm able to see what is the process ID that is actually executing these listening ports. So if you see these on port 135, 445, these are all listening services. And then if you get down to established, these are established connections on the system. And right now I'm getting the process ID, which is great, but we can go a little bit further and we can do NAOB. And what NAOB does is it gives us the process ID, but it also gives us the executable or dynamic link library associated with that process ID. So we're getting a little bit more information. Now, once again, this goes back into knowing what is normal is critical, right? So we've got 135 listening. It's RPC, remote procedure call. It should be. And it was started by services controller host, which it should have been. We also get to this weird one. We got 445. And that's started by process ID 4. And it says cannot obtain ownership information. That is not malware. This is actually the system process. That's normal. It's okay. You've just got to be familiar that that's going to be perfectly normal on that. But if I go down to my established connection down here, and I look, this is my malware. This is actually the malware we created. And we know it's running on TCP. We've got the IP address, local port is 50,767. And it's making a connection to my Linux IP address, which is 172.31.98.175 on port 4444. And then it says it's established. We've got the process ID is 2172. And the name of the executable is trustme.exe. So that is our malware. So what I'm going to do now is I'm actually going to take that information and I'm going to drop it into Notepad++. I'll just drop it into Notepad. What the hell? It's fine. I'm feeling dangerous. And I know that this is a process that is interesting to me and what's going on because, we created the malware there. So what we're going to do is I'm just going to take this and I'm going to copy it and I'm going to throw it into Notepad. Just so I've got this little buffer stack that I can play with. So now I know that we've got trustme.exe is, a process of interest. I know its process ID is 2172. So this is going to become important a little bit later when we're looking at more malware on it. We can also try to get the fully qualified domain names of some of the connections. And this is a command that I really wish worked better on Windows. But if I run this, it's going to see if any of the different remote connections it can resolve. So you can see that we've got Kubernetes. Those are basically it's talking to itself. But then our actual malware doesn't have a domain. It's just a straight IP address it's communicating to. And then you can see down at the very last connection, we got A-003 DC msedge.net. So you can actually get those fully qualified domain names. And if it's actually has one, if it's actually resolved. Static Tier said, Eric Capano did a video on Velociraptor and has been doing some work on it lately. That's awesome. More videos, better. All right. So that actually gets us those qualified domain names. Now, what we've already did the Netstat minus NAOB. Now we're going to get a little bit weird. So I'm going to start with just Tasklist by itself, and we're going to build it up and show you doing cool stuff with it. If I run Tasklist by itself, I just want to show you, this is like, I've been saying this for years. This is kind of a boring process, like a boring executable. And just from looking at this, what would be a good name to name your malware? Like if you're an evil person and you wanted to blend in, what would be a possible name that you could use for that? So if you look, we've got a ton of SVC hosts. Like that's just crazy. This is almost as bad as hitting Control-Alt-Delete and trying to, look and see if there's anything that's called, like Zenith said, definitely not evil. That's what, it's a good place for us to actually blend in on this. So that, I'm just going to be honest with you, that kind of sucks. So what we want to do is we want to fix that tasklist command, and we'll do tasklist // let's go SVC first. So if I do tasklist space / SVC, it's going to tell me what all those SVC hosts are. It's going to say what is the service that is started from that instance of SVC host. So you can see all of this. We have svchost.exe. This one's the NCB service. This one's time broker, event log, NSI, DHCP. So we're able to get a little bit more information about what's going on here on this computer system. So Tasklist can actually be built out to do more and cooler things as we go. The other thing that we can do with Tasklist, we can look at the dynamic link libraries. Brian brought up run DLL 32. All right. So we can look at dynamic link libraries associated with that. So I can see what the dynamic link libraries are associated with, just running tasklist space / M. And whenever I run tasklist space / M, it dumps a lot of just it's really crazy amount of data because it's showing all of the dynamic link libraries that are loaded for every single executable out there, which is nuts, right? That's really, really cool. And the reason why this is really cool is a lot of people are big into like indicators of compromise, and the loaded dynamic link libraries are actually like one of those things that you would create as an IOC. The cool thing about Metasploit Meterpreter is I think it loads 4 or 5 dynamic link libraries, which are some of the absolute core dynamic link libraries that are required for any malware that's making a network connection to process. So you get an idea of what the basement looks like. And I'll show you that here in just a couple of seconds. So let's go ahead and clear my screen. Where did I go from here? Oh, okay. So we've got this command where we're going to do a filter. So we can run tasklist space / M, but we got a lot of data. So what I'm going to do is we're going to create a filter, and specifically the filter is going to be the process ID is equal to the process ID of our malware, which we want to look at. So we've got 2172. There we go. And now it's going to show us the dynamic link libraries that are available for just this particular piece of malware. And yeah, four dynamic link libraries. NTDLL, WoW 64-bit, DLL, WoW 64 Win. I can't remember what WoW stands for, but it's something to do with, it's like compatibility, 32-bit compatibility on, it's like Windows something. God, I can't remember what the hell WoW stands for. But no, it's basically that says 64-bit, 32-bit compatibility. Is what it's doing on that 32-bit binary, what's going there as well. So there we go. So we've got the dynamic link libraries that are actually being loaded out there. Somebody just posted in, it's not World of Warcraft. No, it's not. So John, can we also use tools like Sysmon and OS Query for doing this revision process? Absolutely, you can. You absolutely can. In fact, we have Sysmon running here. Windows on Windows. That's right. It's like, Windows on Windows. So let's go ahead and go to Event Viewer. And I have Sysmon running here. So we'll go to Application and Services. Standard Windows event logs suck. It's a big, long conversation in my class. Go to Microsoft, Windows, and then all the way down to Sysmon Operational. A, B, C, D, E. There we go. Sysmon Operational. Here we go. And these are actual process execution on the system. So you can actually see the commands that I'm running. So you can see that we started cmd.exe here. Like that. And there you can actually see our malware executed in Sysmon. So you can see trust me, and it gives you the full path. ctools trust me. The original description was Apache command line utility. That was the template that Metasploit Meterpreter used to put the malware into it. The original name was ab.exe. Command line is trustme.exe. It executed in the tools folder by ADHD. We've got the login GUID, and we also have the hashes of this particular executable as well. So you're absolutely right. You can use Sysmon to do some analysis of your malware. So good point. A little bit of a detour, but detours are what it's all about when we're creating happy little malware. All right. So there we go. Now I want to get the command line invocation, which in this particular piece of malware is like super duper boring. There's just not much to it. There's no switches or any like cool things like that, but it'll actually be very helpful if you're working in malware that has command line switches or where it actually executed, so you can develop a little bit better understanding. But this allows you to show the full command line parameters of the executable using Windows Management Instrumentation Command, where we dump process, where the process ID equals 2172, get command line. So we can see that. Then we can look at the parent process IDs, like who begat whom. So who made who? There we go. And this shows all of the executables and what the parents of these executables are. So we can see that this is the process ID. The parent process ID is 7376. And you can see that 7376 is cmd.exe. You can see that trustme.exe invoked and spawned off cmd.exe. And so you can actually see that process hierarchy. So you can see that command prompt was ran from this process. This process was ran from the command prompt as well. So just really, some cool little commands kind of as an opening gambit for you to do some analysis on the malware, any type of malware, any type of research. Now, with this particular section, if you notice, we started with looking at network connections. We started with that Netstat naob, or you can even just start with just straight Netstat. And you can look at the active network connections that are on your computer system of interest. And we can see that we have some reverse connections. And if we actually flesh that out, we can get additional information as far as what's going on. Now, the reason why we start with network connections is if we play the needle in the haystack game. If you were to jump straight into the processes on the computer system, that's a lot. Like there's a lot going on. If you were looking at the dynamic link libraries, that's a tremendous amount of data that you would have to sift through to try to identify, if there's anything going on. So with network connections, it's a smaller subset for us to work through. In a real incident, what you would do is you would actually look at each of these with a more critical eye. Like you would look up what are these remote IP addresses that are out on the internet, who owns them, and you would look up, is there anything malicious with these particular IP addresses? You would actually parse through them one at a time. And in one of these videos, I might set it up in DigitalOcean and do this whole thing. So it's all remote, all out on the internet to kind of set that up. But that is baseline. This is a good way to actually start processing it and looking at it. For the next video, what I want to do is the exact same thing, but do it on a Linux system where we just create some really, really basic malware. Start with the network connections and work our way back where we can start doing some analysis on our executables and things of that nature. So we've got a lot of good information. As I said, if you're looking at a recorded version or you're here now, you want to download it. All of my labs for my core classes are out on GitHub. GitHub Strand.js, just go to the intro labs and there's a ton of different labs that are available that you can kind of play with and you can kind of work through as well. Cause we really, our primary goal, yes, Zenith, it is free. Really our main goal whenever we're looking at Antisyphon is we're trying our best to, try to get more people into computer security is ultimately our goal. Also, we're going to kick out a link. I am teaching my intro to security class next week. So if you like this and you want to do like 16 hours hanging out with me, next week we're going to be running the class Intro to Security. And it's all about what are the core 11 things that you need to know right now to try to secure your network. So if you like these videos, check them out. And they're pay what you can. So if you have no money, as I know a lot of people, on Twitch, they're playing video games and, they're like, oh, how am I going to learn this? How am I going to do this? And you're just getting started and you're in high school or you're college and you really want to learn computer security. This will get you the 11 things that you absolutely must know if you want to get into this field. So as I said, really, really basic stuff, but really it's all about the core fundamentals. And if you like it, check out the class. We'll see you next week. So with that, Ryan, actually, let's open it up to questions. Any questions out there as well? What do you need to know like right now, like Network Chuck? What you need to know right now for the class, if you're here and you can download the VM and get it up and running, you can come and show up to class. This is really a great introduction level class. You can ask questions that, people will be like, oh, you're a noob. I don't care. I'm not that bright, honestly. So, anything I can do to try to help people get better, it makes me happy. So that's one of the main goals, that we're trying to get as many people into this industry as possible and help them out. So no, that's all that you need to know like right now. So if you're here, you're doing awesome. Show up. All right. Any other questions before we wrap up this Twitch stream for the day? Okay. Brian said, take the class. It's excellent. He's only saying that. Yes. Yes. Your bonus is coming, Brian. Oh, Network Chuck. We should reach out to Network Chuck. We should check it out. So Ryan, take a note. We gotta hunt down this Network Chuck person. Sounds like he's a good one.
Note taken. Network Chuck.
Oh, Tyler asked a really good question. And China said, are there SOC courses? Absolutely. I have a pay what you can SOC core skills class. You can actually see the labs right here on the screen. We actually do have that class available. It's pay what you can, probably starting up in probably a month. So the question was, how do you catch connections that are intermittent? So as I said, we started with network connections, and there are absolutely connections that are intermittent. One of the cool things about Windows is it doesn't really whenever you run Netstat, it doesn't clean up real well. So even if the process is dead or the connection is dead, it still tends to show up. That's one really, really cool things. And then Justin and Bonsai and a bunch of other people are mentioning Rita, which yet again is another lab in these sections that is there that can actually help you identify those intermittent network connections in a way that you really can't get with the standard like endpoint analysis. But no, it's absolutely something we cover in the class. And by the way, for those of you that have taken the class, we're adding a new lab where we have Rita, but we're actually going to get all the students access to a full live AC Hunter instance for people to play with it. So that's actually coming out there as well. And we just got you a link for SOC core skills. So check that out. So that's pretty good. All right. Any other final questions before we wrap up?
There's one question from Twitch. It looks like our Twitch chat relay is broken. So read this one manually. Will the intro to pen test be on Antisyphon in the future? I don't think I can afford Deadwood.
So intro to pen test will be on demand. I thought it was on demand. Let me check. Let me go to on demand course catalog. I don't know if it's in the main one yet. I'll have to check. Yep. Intro to pen testing is on demand. And let me get a link to you real quick, Ryan. There you go. Best area to use for practice, Hack the Box, MetaCTF. Also try Hack Me. I'm going to throw this over to Rook. I think Derek Rook, if he's still with us, might have some places as well. He's kind of like he's right up there with like IPSEC for cyber range challenges. But my answer for all of those is you need to be doing as many of those as possible. I'm trying to normalize cyber range challenges as much as I can, as much as I possibly can, to try to get cyber range levels and all of that to be accepted as an acceptable replacement for a certification or a degree as well. So Hack the Box and all of them, just please do it. Oh, Mike's doing fine. We're all good. So, and then, with MetaCTF, we actually have the ability for you to actually show off your skills. You can do that with Hack the Box, and you can do that with Try Hack Me as well. We're going to be revamping the interface for MetaCTF, where it's actually going to show not just your score level, but it's going to show where you're at in different core competencies like forensics, network pen testing, web pen testing, and things like that. So that'll be coming up there as well. But I think we lost Rook. But yeah, Rook could come on and talk about, online challenges all day long as well. So, all right. So with that, Ryan, take us out. Thank you so much, everybody. We'll see you in the next session.
Killing it with fire.